Happy learning! Today we're going to talk about interval graphs. All right, so let's start with a definition, and then we'll see some applications. All right, so a graph G is an interval graph if every vertex can be represented as a finite interval and two vertices are adjacent, whenever their corresponding intervals overlap. Okay, so interval graphs basically can be treated as, each vertex could be treated as like some part of the number line. Typically, we go the other direction. We're going to have like a bunch of classes. Suppose you're organizing a school. We're going to have a bunch of classes that want to be, that have certain times. So the times that the classes are running, those are intervals. And these classes are going to need different classrooms if the times overlap. Right? So if math class goes from 12 o'clock to 1 o'clock, and art class goes from 12:30 to 1:30, there's overlap there. So we're going to need different classrooms. And we're going to assign these classrooms using coloring. All right, before we get to actually seeing some examples, what's nice about interval graphs, so the theorem says if G is an interval graph, so if it comes from one of these scheduling problems that I just described, then the chromatic number of G, so the minimum number of colors necessary to color the graph, is equal to omega of G, the click size. Okay, and the click size in an interval graph is just the maximum location of overlap in the schedule. All right, so let's take a look at an example of how to use interval graphs. And then the semester is over. Okay, we've done it. We've made it to the last class. All right, so let's take a look at an example. So suppose we have 5 student groups. And they have times that they want to meet. Okay, so the art club wants to meet from 1300 to 1500, or 1530. Okay, so that's 1 p.m. to 3:30 p.m. Board game club wants to meet from 2 p.m. to 4:30 p.m. Right, you can see there's already some overlap here. So these two clubs are going to need different rooms. The campus activities board, they want to meet from 9:30 a.m. to 2:30 p.m. Okay, drama wants to meet from 11 a.m. to noon. So notice drama intersects with campus activities, but it doesn't overlap with the other ones. So drama could be in the same classroom as art, or it could be in the same classroom as board games. All right? And then finally, esports. They want to meet from 11:15 to 3 o'clock. All right, and we want to make a graph to model these conflicts. And so the first thing we should do, I mean, we could kind of just look at it in this example because we only have 5, but the first thing we should do is draw out a timeline and represent each of these clubs as intervals on the timeline. And then from there, we can make a graph very easily. All right? So here's our timeline. The earliest we see is 9:30, so I'll start at 9 o'clock. And the latest we see is 16:30, so I'll end at 1700. All right, so this is 10, 11, 12, 13, 14, 15, 16. Art wants to go from 1300 to 1530, so we could represent that as the following interval. I'm going to put an A next to it for art. Board game, 14 to 1630. Cab, 9:30 to 14:30. Drama, from 11 to 12. And then finally, esports, 11:15 to 15. All right, so you see how we went from our table to these intervals. And now we're going to go from these intervals to a graph. And we're going to color the graph, and that's going to be how we assign these classrooms to these student groups. All right, so the graph that we're about to draw, the vertices are going to represent the student groups. The edges are going to represent conflicts between the groups, and then the color is going to represent what classroom the student group will be assigned to. All right? So there's going to be 5 vertices. All right, so the 5 vertices, A, B, C, D, E. And now we check. A overlaps with B, C, and E. So there's an edge, AB, AC, AE. All right? B overlaps, we've already done A, with C and E. C overlaps with everything. D overlaps, well, we've already got C, but it also overlaps with E. All right, so this schedule, we capture the information with this graph. Okay, what is the click size of this graph? The click size is the spot of maximum overlap. The click size we could determine is 4, because from 2 p.m. to 2:30 p.m., 4 clubs want to be meeting during that time. So our click size is 4. And so that tells us that our chromatic number is 4. The best we could do is we need 4 separate classrooms so everybody could have a classroom. All right, and so let's now assign colors. We could use the first fit algorithm that we discussed in the previous video. And let's assign A room 1. B could get room 2 because it's neighbors with A. C is neighbors with 1 and 2, so it needs its own classroom. But D is not neighbors with 1, so we could color it 1. All right, and then finally E is neighbors with 1, 2, and 3. It does need its 4th color. All right, so this is how, and now you could imagine if we had an entire university's worth of classes that were being offered, we could do the same thing with a much bigger graph, maybe automate it with a computer to figure out how many classrooms are necessary to have the whole school run. Okay, well, that's all I have for today, and that's all I have for this course. Let me know in the comments what you thought about graph theory, and don't be sad that it's over. Be happy that it happened. Okay, see you next time. Bye-bye.